I have a thread start true, and it is saying so pros and cons first. So now you can see there is an issue. So basically if you wrote the observer pattern and but you don't care about the concurrency, you will face this problem because this list is not synchronized. So how you can save yourself all those all those methods who are those which are changing a list, you can make those synchronized. And oh, this one is, so now in this case we are able to manage, but this is expensive because this synchronization only give one thread at a time, and then all other threads are waiting for to access that. So it depends what type of uh, scenario you are making. Now this is the one. uh, Also we can go, uh, if I'm not wrong, I think copy on write list, and I can say observer. So I think this should also fix this issue. Yeah, so there will be no one, but this is not a good use case of a copy on write. You can read more what is copy on write. Okay, this is done. Now we can discuss about uh, can we improve the time complexity. So in this case, if you see, once I will remove, it's a big of an operation. Like for example, if there are hundreds of observers who are registering and one of them wants to remove that himself, in that case is going to be pretty bad. Can we improve this? I think, okay, if I go this, I'm saying, okay, I'm going this list as a mutable set. In this case, oh, okay, I need to change here this thread, no need to do this, and no need to. So now in this case what happened, I improved, as you are aware of. So basically set is internally implemented from the hash map, and hash map, the key is always the value which we are giving, and the map and the key value is always null. So that is the internal implementation linked hash set. So now there is a more discussion starts, but in this case my removing is a big O of one operation. Yeah, but I'm using more space, but the removal is a big O of one operation. Every time I will give this, it will directly go there and then remove. Also in this case, because it's a set, it will not take the duplication. Now we can discuss one more problem, or not an issue, but most of the time as per my experience, when we are using observer pattern, we need to be very careful with the observers. Otherwise we can do memory leak easily and we will not aware of. So for example, I have a local scope. This is a function, and this notification center, my observable is for, it's a global scope, and I have a local observer, and I'm writing some code here. Then what I did, I'm saying, okay, register this with global local. Okay, so now in this case there is a memory leak. How? So okay, maybe we can we can change this. So this is for example, this is our some kind of a UI, and it's a different screen with which has less scope. So I started my main screen where I have this global scope observable, and then we started somewhere here a different screen which has kind of a local scope, but I have an observable access to the global scope. Now at this point I added a new observer which is doing some work, and here update, we are doing some work related to that local scope, like this detail screen work, and then I added, and I forgot to remove that. In that case now we have a memory leak. In some cases that can crash, but memory leak is 100% there. So why this is a memory leak? So once we started this local scope, this function is called in a stack, And once function is complete, it's done, and now we don't have access of this observer, so I can't remove. So in this case, when the garbage collector will try to collect this, it will check and it will say, oh, that is already available inside of this global scope, so there is a reference. But the problem is this update, if that is doing some calculation, it's still okay, it will not crash, but still it's a memory leak, it's useless work. And second, if there is a UI related some stuff, for example, I have some kind of a UI, so I have a reference to that UI. In that case, the whole detail screen or that second scope screen, the less scope screen, is still available in a memory, because this access is still there. And now we have, you can see the impact on your RAM, and it's pretty bad. So that is the biggest pain point when you are working with the observer pattern. And you can't do a lot here because it depends on the person who is writing observer. So you need to be careful, you need to discuss with a team, or you need to review code properly. Like if you are registering something, you are adding something, you need to remove before that scope is going to be outside, otherwise there is a memory leak. Now we can move towards the real world implementations.